Welcome to Spring LIB.
In this numerical, the rated speed of the motor is 3600 revolution per meter. When the power is turned on, the unit reaches its rated speed in 5 seconds. When the power is turned off, the unit caused to rest in 70 seconds. The number of revolutions that the motor executes in reaching its rated speed and in costing to rest is to be determined. Now, in the first case, we are going to assume uniform accelerated motion. So for that, we can write the equation that is omega is equal to omega 0 plus alpha t. Let's remind this equation as number 1. Also, we can write it in the form of theta. So theta will be equivalent to theta 0 plus omega 0 t plus 1 half alpha t square. Let's remind this as a number 2. Now moving further and to solve the first part, at startup, the condition is over here. We are having theta 0 is equal to 0 and omega 0 is also 0. So at time t is equal to 5 seconds, the omega is 3600 rpm. So first of all, let's simplify the omega. So omega will be equivalent to 2 pi into 3600. This calculation we are doing just to get the time in the form of seconds to the minute. So the answer will be 377 radian per second. Now in equation 1, we are going to put this omega value. So we will get the alpha. So this is our equation 1 and we are going to put omega 0 is equal to 0 and omega will be 37. So we will get the alpha. So from equation 1, I can write alpha will be 75.4 radian per second square. Now in equation 2, in this equation, we are putting omega 0 is 0 and alpha will be 75.4. So we are able to get the theta value. So by putting this all the values, theta will be equivalent to 150 revolutions. Moving further to the next part, the costing to rest at theta 0 will be 0 and omega 0 at 377 radian per second. These are the known conditions. Now we are going to put this at time t is equal to 70 seconds and omega is 0. So again we are going to use these values in equation 1 and 2 to get the answer of alpha and theta. So by putting this in equation 1 and 2, we will get alpha will be equivalent to 5.385 radian per second square. And by putting it in equation 2, we will get theta that will be equivalent to 2100 revolutions.